Good morning. My name is Scott Polson, Vice President of Enrollment, Marketing, and University Relations.
And I am Kwok Nam Tran, the Department Chair of Computer Science.
And we would like to welcome you to the University of South Dakota's Robotics Competition. This year's contest has been changed in format to make it more competitive, as well as enhancing the scholarship opportunities for students, which we're going to give to the top 10 teams.
To help you to prepare your teams, we offer several training videos on how to assemble the robotic kit, how to install and using the program developmental tools, how to have basic techniques for robotic programming, how to use the sensors, and how to have some advanced algorithms and techniques for programming your robots.
We're excited about these additions to the program, and we look forward to welcoming you to the University of South Dakota in the near future.
Hello and welcome to the part 1 of the video tutorial for the assembly of the ActivityBot robot kit. My name is Alex.
My name is Mitchell.
I'm Shayla.
I'm Naveen and welcome to University of South Dakota.
This is the first annual robotics competition at the University of South Dakota.
For this competition, your team will be tasked with assembling and coding a robot.
We are all excited to see you on the campus of University of South Dakota, and stay tuned for more for the event.
This right here is the assembly box for the robot kit that you should have received from the university. Inside of it there are numerous parts and an instruction manual, which you'll see right here. This contains all of the instructions for how to assemble this robot on your own if you are not using this video. Right here in this gray packaging is the main motherboard used on the robot. You want to keep this out for now. Right here in this gray electronic packaging is all the various sensors and electronics for the robot. You will need to set this aside for now, as we will not be covering that in this video. Right here is a basic screwdriver. This next package contains a couple other parts. It is the main robot frame, and the servos for making the wheels move, and the battery pack. This package right here is the USB cable for connecting your motherboard and robot to the computer for uploading code. This right here is another sensor that you will also set aside, as it will be covered in the next video. This packet right here contains the wheels and various other parts and a package of nuts and bolts for use of the assembly of the robot. And there should be one last package in here that contains various wires and sensors that will again be used in the next video.
Hi, now we will assemble the robot, and let's see the step-by-step procedure to assemble the robot. This is the encoder bracket and this is the encoder sensor. So here is the infrared sensor. And this is the encoder cable. We would repeat the same procedure for the other side. This completes the step 1. Step 2. In this step, we assemble the robot wheel, and we need to slide the tire into the robot wheel. Repeat the same procedure for the other wheel. This completes the step 2. Step 3. In this step, we are going to take this small robot chassis, and we will first insert the rubber grommet. And then we are going to take the 1-inch round standoffs So these standoffs will be the base for the microprocessor that we will be inserting in the later steps. Repeat the same procedure on the other side. So this completes our step 3. Step 4. In this step, we need to remove the screws from the servo motors. These servo motors are the ones that will be powering the wheels of the robot, and these screws and this should be retained for step 11. Repeat the procedure for the other motor as well. This completes our step 4. Step 5. In this step we assemble the right servo motor. So we will take the motor and we will put it into the chassis on the back side. So this is the way it should come, and then we would insert the screw and then we will also use the nylon core lock nut. You can tighten this using the wrench. Then we need to put the other screw. Once we tighten the screw, we need to push this wire from the servo motor into the chassis and pull it on the other side. And this completes our step 5. Repeat the same procedure on the other side for the step 6. Step 7. In this step we are going to mount the right encoder, this is the infrared sensor, onto the chassis of the robot. So we need to fit the encoder in this way. And we use the 3/8-inch nuts and the lock nut bolts in order to tighten the robot sensor encoder. So this completes our step 7, and repeat the same on the other side, and that would complete the step 8. Step 9. In this step we will mount the battery pack onto the chassis of the robot. So we would need to use the 2 outer big screws. So we will use the round standoff and the flathead screws. So we need to fix this part of the round standoff as well, and this completes the step 9. Step 10. In this step we will mount the rear side ball onto the chassis. This ball works as the rear side part of the robot, and we need to insert the quarter pin. Once we have inserted the quarter pin, we need to bend one of the tip of the quarter pin, and this completes our step 10. Step 11. In this step we mount the drive wheels onto the robot. So this is our servo motor and this is the wheel of the bot, and these are the screws that we have saved from our step 4. So we need to mount this using these screws. Repeat the same procedure on other side. This completes our step 11. So this is the propeller activity board, and before we move on to the step 12, we would like to make a point. Our body might have some static energy, so in order to ensure that we do not have any static energy before opening and touching the circuit board, it's good to touch a board or something so that you don't burn the board. And once we do that, we can go ahead and open this propeller board. This is the heart of the robot. This is a very powerful propeller board, and as we see, we have a white breadboard. This white breadboard is used to make the connections. You use the electronic parts like the resistors, the capacitors, the sensors, everything goes into this board. And this is the heart of the board. This is the 8-core microcontroller. This is the one which is responsible for executing the commands that are programmed by you. And this little black one is the EEPROM, which is also called as erasable electronic programmable read-only memory. All the commands that are provided from the simple IDE software, which we'll explain in the later video, will be stored in this particular small part of the board, and the commands will be executed from here. And you also have an audio jack which could be used with a small speaker, and you can play some songs or any other audio files. And then you have a power jack which will be used into the board, and this is pretty much what we'll be using into the next step, and this will be the heart of the robot. So let's move on to the step 12. Step 12. In this step we are going to mount the board onto the top of the robot. So let us take the 7/8 inch screws and use the nylon washers and the 1/2 inch round . And we need to screw them onto the board, which in turn will be screwed into the 1 inch round standoff. There may be a bit misfitment, so it's good to unscrew this again, screw them both together. These standoffs will be used again when the sensors are assembled onto the robot, and then we need to screw the small screws into the back end of the board. This completes our step 12. Now your robot is ready, it's assembled and ready to play.
In future videos, we'll be showing you how to attach sensors to the robot and take a look at the IDE, which is the development environment for coding the programs for the robot, take a look at how to make basic programs and how to upload them to the robot to make it work. We look forward to seeing you in April at the University of South Dakota, and go Eagles!